Hello, you nines. Sorry I can't be there with you at the moment. I'm teaching Year 12 step-up class. I realise many of you want to get your exams back. Some of you might not do, but you all should do. I want to be there when you get them back so I can answer any questions you have. So for 9H, that'll mean wait until lesson 6 today. For 9G, that means wait until lesson 1 tomorrow. For today's lesson, however, you're going to do a couple of interesting problems, and then you do a booklet on counting. First problem to have a shot at is to do with quadratics, and it's a little bit dicey. Essentially, you get two dice, and you roll them together, and the sum of the faces shown is B. That gets substituted into the quadratic here. You then roll the two dice again. Their product is C. Alright? The question is, what is the probability that a quadratic generated this way can be factorized? So generated by two dice rolls, what percentage of them can be factorized? Let me walk you through a couple of examples. So I could bring up a digital dice work nicely, roll, 3 and 6, adds together to make 9, so I would get x squared plus 9x. Now, to get the second number, I take my dice, roll them again, 2 and 4. 2 times 4 is 8, like that. So now I'm looking for two numbers that multiply together to make 8 and add together to make 9. Well, lucky day, because they do. Clearly, 1 and 8 would work. So we could factorize this into x plus 1, x plus 8. Let's try another. Roll. Oh, what are the chances? In fact, you should be able to work that out. 9. X squared plus 9x. Let's go again. Roll. Plus 7. Sorry, 2 times 5 is 10. So we're looking for numbers that multiply to 10 and add to 9. And there are none, so it's a no, or we can't factorize it. And the question is, if we did this thousands and thousands and thousands of times, what percentage of those quadratics could be factorized? Alright, second slightly dicey problem. Imagine making a cube of 8 dice, like the one shown, so that the sum of all the points, or all the dots on each side, adds up to the same. The one pictured, for example, adds up to 14. This is one face. That actually doesn't help with highlighting, does it? One face, another face, another face, and you can see how they've been put together so they all add to 14. The question is, how many different combinations are there with a face sum of 14? And you note this one has a face sum of 14. So in total, how many different ways can we do this? All right. The way this will work this lesson is you'll write your name, your answer for question A, your answer for question B on the whiteboard. You only get one guess at each, and it has to be done by the end of the lesson. At the end of the lesson, the relief teacher will look at the answers I've given them and the answers on the board, and will award a Toblerone, cue relief teacher waving big Toblerone, to the person who gets the closest answer for problem A, and will award a Mars bar for the person who gets closest to problem B. Once you've put your two answers on the board, and I'm completely okay with you taking most of the lesson to answer some of those questions, because they are hard, I'd like you to start a booklet on counting, because you need to know how to count. You're probably thinking, I know how to count. Let me tell you now, no you don't. Read the booklet, it walks you through some beautiful problems, and you'll come out at the end of it learning a lot more about counting. Thank you very much, and I'll see you soon with your exams.